Welcome to Spaceverse, your portal to cosmic adventures. Imagine traveling back in time 10 billion years into the past to a period when the universe was wildly active, star-studded, and chaotic. A time known as cosmic noon. It was a defining moment in the universe's 13.8 billion year history, a peak era of galaxy formation, black hole growth, and star birth. And now, thanks to the extraordinary power of the James Webb Space Telescope, astronomers are seeing this era with unprecedented clarity. Today, we're taking you into the heart of cosmic noon, where black holes raged, galaxies collided, and stars were born in staggering numbers. It all begins with a groundbreaking study led by a research team from the University of Kansas, or KU, who are using JWST to investigate what they call one of the most explosive and transformative periods in the history of the universe. At the center of this research is something truly fascinating: raging supermassive black holes located at the heart of distant galaxies, caught in the act of rapid, almost uncontrollable growth. But let's rewind for a moment. What exactly is cosmic noon? Cosmic noon refers to a critical era that occurred roughly 2 to 3 billion years after the Big Bang. This was the time when the universe reached its peak in star formation. Stars were forming at breakneck speed, galaxies were growing rapidly, and black holes were consuming matter faster than ever before. Astronomers believe that nearly half of all stars that exist today, including those in our own Milky Way, were born during this vibrant chapter in the universe's story. To study this phenomenon, the KU team launched what they call the MIRI EGS Galaxy and AGN Survey, or MEGA for short. MIRI stands for the Mid-Infrared Instrument aboard JWST, which allows scientists to observe through thick clouds of interstellar dust that normally block visible light. These dusty galaxies, full of hidden processes and raw energy, are the perfect targets for JWST's infrared vision. The mid-infrared is where dust emits its glow, and where JWST shines the brightest. Our goal is to gain insight into the star formation processes, star production rates, and most importantly, the growth of the black holes at the centers of these galaxies, said Dr. Alison Kirkpatrick, lead investigator of the MEGA project. And that's exactly what they set out to do by focusing their powerful infrared gaze on one of the richest patches of sky known to astronomers, the extended Groth Strip. Located near the Ursa Major constellation, the extended Groth Strip might appear unremarkable to the naked eye. But to astronomers, it's a gold mine. Although it's only about the size of the full moon in the sky, this region contains over 10,000 galaxies. Yes, 10,000. Using JWST, Kirkpatrick and her team began a detailed survey of this area, hunting for galaxies with black holes that were actively growing, swallowing material at phenomenal rates. Now, black holes themselves emit no light. But when matter spirals into a black hole, it heats up due to friction caused by the intense gravitational pull. These superheated regions, known as active galactic nuclei or AGNs, glow so brightly they can outshine entire galaxies. And that's exactly what JWST spotted: galaxies with glowing centers, harboring supermassive black holes in their prime. Some of these galaxies, astronomers believe, are early ancestors of the Milky Way. By studying their light across multiple infrared wavelengths, the team can track how fast these black holes are feeding, how quickly stars are forming, and how galactic mergers might be shaping their evolution. But this kind of science doesn't happen instantly. It takes months, sometimes years, of painstaking work to analyze the data pixel by pixel. Team member Bren Backhouse explained what it's like to work with JWST's data. First, you receive raw images captured through various filters, just like taking photos with only red, blue, or green light. These filters reveal different parts of the galaxy structure and composition. But because the telescope moves slightly between exposures, Backhouse said, the images don't align perfectly. Some are out of frame, and we have to correct for that. There are also known quirks in the data, like a scratch that appears in every image and patches of dead pixels that must be removed or corrected before the data becomes usable. Once clean, the images are analyzed using a method called photometry, measuring the amount of light passing through each filter. From this, astronomers can build detailed profiles of each galaxy, unlocking clues about their makeup, structure, and activity. For me, this was my first time working with photometry data, said Backhouse. It was a huge learning experience, and an incredible feeling to be seeing these galaxies before anyone else in the world. So far, the MEGA project has logged an impressive 67 hours of telescope time, with another 30 hours already approved for future study. That's a significant investment. And under current JWST policy, the COO team gets a one-year head start, exclusive access to the data they collected before it becomes public. This is the largest amount of JWST data we brought to COO with a principal investigator here, said Kirkpatrick. That means COO students are the first in the world to work with it. After a year, it becomes available to the global astronomy community in its raw form. But here's the exciting part: you don't have to be a professional astronomer to get involved. Through a citizen science initiative called the Cosmic Collisions Project, hosted on the Zooniverse platform, anyone can help identify galactic mergers and classify galaxies captured in the MEGA survey. That's right, you can help explore the cosmos and contribute to real scientific discovery from your own computer. As for the official research findings, the team's initial results are now available as a preprint on Arxiv, and they're set to be published in the prestigious Astrophysical Journal. And the discoveries are just beginning. The data collected by JWST is already changing what we know about how galaxies and their black holes formed and evolved. It's helping scientists understand the intense, dusty environments of early galaxies and how the hidden hand of gravity shaped their fate. As JWST continues to peer deeper into the universe and further back in time, the secrets of cosmic noon are slowly being revealed. Galaxies that were once shrouded in mystery are now seen in exquisite detail. And thanks to projects like MEGA, we're starting to connect the dots from the chaotic youth of the universe to the mature galaxies we see today. One thing is clear: we are witnessing a revolution in astronomy. And we're only at the beginning. And while the JWST continues to deliver awe-inspiring images, it's also raising new questions. Why were some galaxies able to grow their black holes so quickly while others remained quiet? What role did galaxy collisions play in igniting these violent feeding frenzies? With every new observation, scientists are discovering that the early universe was more dynamic, more chaotic, and more complex than previously imagined. Each image from JWST is like a puzzle piece, and with MEGA and other large-scale studies, we're slowly assembling the grand picture of cosmic history. The implications stretch far beyond academic curiosity. By understanding how galaxies formed during cosmic noon, we gain insight into how our own Milky Way and even our solar system came to be. These observations help refine our models of galaxy evolution, improve our simulations, and may even one day assist in answering one of humanity's biggest questions: are we alone in the universe? With tools like JWST and the curiosity of scientists and citizen explorers alike, the journey through the cosmos continues, with more discoveries waiting just beyond the veil. If you enjoyed this journey into the early universe, be sure to give this video a like and subscribe to Spaceverse for more deep dives into the cosmos. Until next time, keep looking up, stay curious, and remember, space is vast, and the story has just begun. This is Spaceverse signing off, for now.